How many different ways can a student match 14 terms with their definitions if no term or definition can be used twice? And they want us to leave the answer as a permutation in symbolic form rather than actually evaluating it. First of all, you've got to understand what they're asking. We've got 14 terms, maybe they're just words, like set, union, intersection, there are 14 of them, and they're being matched with their 14 definitions. What is a set? A set is a collection of objects. So you've got 14 terms, 14 definitions, and you're going to draw an arrow from each term to its definition. So that's a one-to-one matching. That should tell you that this is a permutation problem, because that's no different than putting people in line. If you wrote each definition on the floor and gave each person index card with the term on it and told that person to go stand on the position against the wall where that definition was, that would be like lining those 14 people up in a row. So I'm trying to help you understand that when you look at a new problem, one of the ways of handling it is to think how it's similar to a problem you've worked before. So this is a prototypical permutation problem. The term is like a person, the definition is like the position in line. So all I'm really doing is lining 14 people up and counting how many different ways I can do that. So the answer is going to be 14 factorial. There are 14 factorial ways that I could draw an arrow from a term on the left to its definition on the right. Problem is, they ask us to leave the answer to permutation, not a factorial, but that's not a big deal because we know that a factorial is a permutation. It's just you take all the objects. In other words, R and N are the same thing when you have a permutation. So rather than writing as 14 factorial, they want us to write it as a permutation, and you simply write the same number twice. So in reality, instead of us writing it like this, they're asking us to write it as a permutation. And you could actually evaluate that. I won't do that here, but they did want the final answer as a permutation, not as a factorial.